Okay, just to show you how we do this question, right? Okay, I will draw the flow, right? So actually what we can do is we always start from the part where they show you a bit of a product, okay, which I start from F, okay, they will give you F. So they say E plus ethane, what do you call this? Ethane 1,2-diol form F, right? So which means you can try to draw E because you can work backwards. Okay, if you look at it carefully, you have an ester over here, right? You have ester over here. So ester is formed from carboxylic acid and alcohol. And if you try to break the ester, you normally will do this. You add a H here, and you add OH and a OH here, right? So you can work by doing that, you know what's E already. So I'm going to draw E over here. So E is supposed to be C double bond O, OH, CH2, C double bond O, OH. Okay, this is E. So after that, if you work backwards, if you just add acid to form E, it means the acid was actually went to these two places. So I can actually draw C also. So C is C double bond O, O minus, CH2, C double bond O, O minus. So when you add acid, the acid went to the COO minus on both sides. So because this is idle form, if you remember idle form, you work backwards one more time, you can get B, all right? So let's try to draw B. So this one, B should look like this, all right? Okay, we'll use a different color. B should look like this, CH3, C double bond O, CH2, C double, so it's working backwards. So you know that when it undergoes idle form, normally what you do is chop off the CH3, right? And then you get your 2CHI3. All right, then what I say last time, you always add O minus here and O minus here. Can you see that? So that's why you will get these products. Okay, so that's why you can get this. All right, so this actually your this is actually your B. All right, so sorry, this is actually your B. Sorry, this is actually B. Okay, so this is actually C. Okay, so there's B. All right, so I'll draw B again. So B is supposed to be drawn this way. C double bond O, CH3, CH2, C double bond O, CH3. Can you see that? So you make sure that it fits in the formula C5H8O2. All right. So now this part is a bit tricky. They say A has a double bond, okay, because they mentioned about cis trans, yeah, cis trans, and it also has a chiral center. All right. Okay, but I want to see how many double bonds there are. Okay, how many double bonds there are. So this is how I go about doing it. So I taught you a formula which called degree unsaturation, C plus 1 minus half H plus halogen minus nitrogen. So this can tell me how many double bonds there are. So 7 plus 1 minus half. I'm doing for A, 14. Okay, so this gives you 1. So I'm pretty sure that A only has one double bond. Okay, only one CC double bond. So where would the CC double bond be? So since you know what is B already, right? Let me just erase this. Since you know what is B, you have to understand that when it undergoes oxidation, there's an alkene somewhere. So you have to think in this way. Okay, this is how you think. So I'm very sure the double bond was actually over here at first, right? The double bond was over here at first. So it's CH3, C, CH2. Okay, here would have the double bond. I probably know that this part will be the double bond first. All right, so the CC double bond over here. Okay, but there's only one double bond. Okay, there's only one double bond, and you realize that this part is both of them are ketone, right? Ketone here, and this one also is a ketone. Both are ketone. Huh? Okay, but there's only one CC double bond. So this part here, at first, didn't have a CC double bond. Okay, this part cannot be a CC double bond. So what is a ketone? What gets oxidized to a ketone? So you must know that a secondary alcohol gets oxidized to a ketone. Right, a secondary alcohol gets oxidized to ketone, which means, in fact, I will have drawn a secondary alcohol here. Okay, so I would, instead of having a ketone now, I would think of it as a secondary alcohol. So I have drawn this. All right, because I know a secondary alcohol will be oxidized because it's oxidation, right? Oxidized to a ketone, so you get a ketone already. Okay, and this actually is my chiral carbon. Okay, this is my chiral carbon. All right, and if you look at the formula, there's actually 2 oxygen. Okay, let's think through. Even up to now, okay, up to now, right? What have I drawn? How many carbon have I drawn? 1, 2, 3, 4, 5, 6. I have drawn 6 carbon. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've drawn 10 hydrogen. And I've drawn 1 oxygen. Right, now see 3, 4, 5, 6, 8, 9, 3, 6. Okay, yeah, good. Okay, so but you look at the formula, it's C7H14O2. Right, which means I still have to put in 4 more H, right, 1 more carbon and 1 more oxygen. Right, so how do I do that? Okay, so you have to play around. Since they already told you, in fact, since they told you, right, it has a cis trans, so these 2 groups must be different. Okay, so these 2 groups must be different, and I only have 1 carbon, right? I only have 1 carbon, and the thing is, when you oxidize it, you must get 2 CO2, right? That's why you get 2 CO2 over here, right? Okay, so this is a bit tricky. So the answer is actually like that: is H, C, H2, OH. All right. So this is a bit tricky, yeah. So this is where I think is a bit difficult. So you're supposed to draw this part here. So this actually has cis trans because this group here are different. Then H and this group are different. Okay, but let's see what happens when it gets oxidized. So when it gets oxidized, you're breaking the double bond here, right? Okay, the breaking double bond, and the secondary alcohol gets oxidized, so you get ketone and ketone. So you actually get, you already got your, which one, a B. Okay, you actually get B already. Okay, but let's look at this side here, this part here. What happens to this part? So in fact, when you oxidize it, it becomes C double bond O. Then this aldehyde here becomes COOH. Okay, right? So COOH. Okay, this is actually, look at it carefully, this is actually a primary alcohol. So you oxidize, it actually becomes carboxylic acid. All right, and I did mention that this one is the special case. This is this is known as ethane dioic acid. Okay, this is a special case with KMNO4. All right, it can be further oxidized easily to CO2. Okay, to CO2 and H2O. Okay, if you try to balance it, I think you just have to, here is how many O, here's 5 O, so here you have to plus O here, one O here. So this O here tells you is oxidation. And why this one gets easily oxidized? Because oxygen is electronegative, delta minus, C delta plus. Delta minus, C delta plus. So this one actually can be easily oxidized because both carbon are delta plus, and actually they will repel and it will actually break quite easily. So you end up getting 2 CO2 and H2O. All right. So this is actually how I would have done the question. Okay, it's just that this part is, I feel is a bit more tricky because you must be able to see that you get ethane dioic acid, then which will be further oxidized to CO2.